Hello, I'm Tibor Halter. In this video I want to give you an idea of what Boomla is and how it works, why it's different and why it will be very interesting in the future. First of all, Boomla is a website builder. There are three things that make it super interesting, hopefully for you. The first is it's super simple. It is designed to be simple. That was everything that Boomla evolved around. And it's both simple for end users via a drag and drop interface, and also for developers, as I will show you in, on my computer. The second very important thing is Boomla is quite fast, as you will see. And third, it's programmable, just like website builders or frameworks like WordPress. If I had to compare Boomla to other products on the market, it is probably closest to WordPress because it solves the same problem. It is a CMS, but the way WordPress is architected makes it extremely complex because there are so many components in the system that are stuck together to make it work. For example, there's Linux, there's the database, there's Apache, there are various systems that are kind of solving the problem, but not really offering an integrated solution. So for example, there's, if you want to store data, there's a file system and there's the database, which work totally differently. On the web, we want transactions, but the file system, because it came with Linux, is not a transactional place. Also, the database and the file system are like opposites of each other because one stores structured data, the other can store big data, but none of them have both of the properties. So the idea behind Boomla is we want to take the ideas that are spread all over the parts of the system and essentially glue these ideas into one coherent system and offer that, because that way we get a much simpler solution. All right, let me start with showing you how Boomla works for the end users, and then we will step down and see how Boomla works under the hood, which will be hopefully even more interesting to you. But without trying it on the front end, like the way it works for end users, it doesn't really make sense because that was what kind of drove the entire thinking in the design process of Boomla. So stick with me. So this is a Boomla website. On this URL, I will keep this up for a while, so in case you wanted to click around in this, feel free to do that. So let's go to the play menu because I want to show you how it works, right? So let's open the edit tab the new tab, and drag a heading onto the page, then new text, and go edit, change the title to title, just add whatever text, make it bold, etc. Then save it, and there you go, it's permanent. If I want to add a new text, I can add it at the end. Then I can hover my mouse over them and grab this icon, and it helps me sort those things. By the way, we can turn on structure view, and that helps you see the size of the elements, so it's easier to have an idea of what you're doing while you are dropping things. Then if I wanted to make a copy, for example, I can just click on this icon and say paste after, or I can say paste before, or whatever you want. I can also delete things, similar way as you would probably expect. Let's create a new gallery, but we don't have a gallery in the toolbar, so there's an install more button. Let's click this, go to apps and find the gallery. Actually, it's here. We can either click this install button to install it directly, or open this website, which is the application itself. So in Boomla, this is called, well, the gallery is an application, but the entire thing is a package, and every application is bundled as a package as a website. So the file system of a website is a thing that you can install on your own. So in that case, the entire website, the entire file system of this website will be kind of copied into your website. So we can either click this install button here, which will do the same as if we click this install button here. Let's go with this meetup, and there are various branches. I want to install it on this branch. Okay, should be done. Refresh, new, there's a gallery, put it maybe below this one. And I want to upload some images in here. they are uploaded, they are resized on the fly, and ordered in a way so that makes it nice. You can order things the same way in the entire system. So you can see those icons. I can just grab this image and move it, or any single one of them. So again, they are resized on the fly. So actually, let me open this for you because it's quite interesting. So here it's actually a background image. Open a new tab, so it's resized. We could, like, the system is generating the sizes automatically, but there are set number of sizes that you can use, so then you can use a smaller one. So because it's dynamically resized, you don't have to do anything with it. All right. Let me show you how undo works. So undo redo is implemented for the entire system, and it's an undo functionality for the file system. In Boomla, everything is stored on your file system. This is not the file system that you think it is. Bear with me or stay with me because we will get to this. So if I click undo, we can undo everything we have done. Yeah, there's nothing to undo. Actually, I want to redo it to have some things around. These are the uploads. Okay. By the way, for positioning, there are three ways to position things. So there's this before, which I want you to imagine as an arrow pointing like either above or to the left of this thing which we are dropping something next to, or into it, or after it. So for example, if I want to move something onto this page, or actually let's create a new page here after that one. Here's an empty page. So let's say I want to move this gallery into that page. In that case, I will be dropping it into the page and go there, and the gallery is there. Same way, if we create a new gallery here, behind this one, I want to move this image in there, I'm going to move it into the gallery. It's actually going to be stored in there, as we will see, which is super cool. All right, there's a file panel. If you open this, you can see there are two galleries on the page. The first gallery is containing 4 images, and the second one is containing 1 image. You can also hover your mouse if you are in structure view or this area, and then it shows what you are hovering your mouse over. Then we have a context menu. So let's say if we click this, we can change the number of maximum images in a column. So let's say if we set it to 5, then all the 4 will fit into a single row. If we say it should be maximum 2, then we will have 2 in a row, etc. We also have a customization, every app can extend this context menu. So there's a customize gallery button here, where we can say, for example, that we want to change the margin to, I don't know, 10 pixels. Okay, and then the gallery will look differently. Every application can again define custom anything here. This is this very page is defined by the application itself, so you could have your custom form, whatever you want. All right, then let's see version control. So I said the Boomla file system, everything is stored in the Boomla file system. That allows us to version control it, which is also built into the system. So let's say I'm happy with my changes. I want to commit it to the story, which I call, or in Boomla it's called a story, because Git, well, is the most popular version control system, but there you can rewrite the history. And Boomla comes and says, well, if you can rewrite something, whatever it is, it's not the history. So in Boomla, we call what it is. It's a story. It's essentially a list of changes, how the website came to be. But if you rewrite the history, you can, well, change the story of your website. So here, we are happy with the changes, edit, contents, just whatever. Okay, then we can go, so this is the website or the branch we are on. We can list all the changes, so edit contents. That's what we have done right now. We can see our apps. So if we are in the control panel, on Boomla.com, if you go to control panel and when you're logged in, you can go to websites and meetup. And this is where I was. So this is the website, and these are the branches of the website. This is the master branch. You can think of it like that. So here are the apps. These are applications which are installed in the system. So if you want to update them, you can update them all at once. Or if you want to install more, you can just click the Boomla store, which is identical to clicking here and grabbing whatever you need. All right, you can also check out things. So if you want to check out an earlier version, go to story. The one before we added contents, check out, let's call it old. Meetup old, let's open this and go to play. And as you can see, the contents are not there yet. So it worked as expected. Okay, I'm going to delete this one. Just copy it here. Yes, I want to delete it. Fine. So this is roughly what I wanted to show you, what it's like to play with the system. Okay, so let's go into the implementation details because that's even more interesting. So the purpose of Boomla again was to fight complexity. That's because there are, as said, there are so many components and they just don't quite fit together. And there are so many languages you have to learn. You have to, just to store some data in a database, you have to learn SQL, you have to learn managing a database, system administration, you have to learn Linux commands, you have to learn to secure the system, get your SSL certificate. It's just overwhelming if you are starting out. So what Boomla does is essentially, I'm not going to repeat this. Another important part I want to emphasize is that Linux itself is very much process oriented. So in Linux there are processes, and on the web we are using a transactional model or architecture because, well, there are requests and responses. And our primary data store is the database, which is transactional. So these ideas kind of feed into a neat system. And if you travel back in time, like 10 or 15 years, it was so easy to create a website. You just opened, you create a new directory, registered it in Apache, and just started editing pure files. There was no process running in the background that could stuck in and hide processes, and there was no complex continuous integration pipeline or whatever. You just copied files and they kind of just worked, and it was super simple. But the way our websites became more powerful and more complex, we kind of lost that simplicity. And I want to emphasize that losing all this was not because it can't work in a simple way. It was rather like we were always adding new concepts to the pile and we never subtracted any of those. So Boomla is an application platform. The difference between a platform and a framework is that frameworks and stacks only add to the system, or yeah, that's true. They just add. They don't remove anything. But a platform introduces a new layer, platform, but it also hides all the underlying complexity. So thereby it can introduce a new and ideal world, which is so much easier to program because you don't have to know about all the underlying details. If you think about it, on the web with frameworks, there's a tendency that databases are kind of our main data storage. And that's because in a way, for a developer, it's so much simpler to work with it because it's transactional nature. But if you want to start working with bigger, for example, image uploads, which are bigger files, then you are kind of in this stupid situation that you don't know, like, shall I go and store it on the file system, or shall I store it in the database? And there's no right answer, right? I mean, if you store it on the file system, you don't have transactions, and if the file upload breaks halfway through, then you have to do your own rollback implementations, and it just gets messy, and nobody does it. And if you go with the database, then, well, your system will become slower because databases were not designed to serve files, because then the file would go through Apache, then through, for example, if you write, well, WordPress is kind of the biggest framework so far. So if you use WordPress with, say, Apache and PHP, then the image goes, so the request goes to Apache, which starts PHP, which is then starting like communicating with the MySQL database, fetching the image from the database, and then it's copied, well, sent over the wire to the PHP daemon, which is then sending it to Apache, and then it's sent to the user. So it's just, why do all this extra work to get this image to the user? So there's no right solution. So Boomla was designed to be simpler for both end users and developers. And well, I'm a developer, and I kind of designed it for myself, like to make it a system that I would really enjoy using. And one of the requirements was that it has to be a cloud-based system, and it has to work locally as well. So I just don't like the idea of having to rely on the internet to get my work done, and if anything goes wrong with my connection, I just can't get shit done, which is crazy. So Boomla, for that reason, is an immutable platform, which means that your website, or you can have more of them on the same platform. This website is, let me start again. So you have this Boomla platform, and the one you have installed on your own machine, which is like just a binary, and the one that is running in the cloud has to be identical. So what does that mean? You're not going to install something on the platform that is not part of your website. There's nothing in between. That's why there's this red line. So for example, if your platform was Linux, and you install Apache on your platform, then you have changed your platform. Now there's no guarantee that if you move your site from one Linux installation to another one, that it will just work, right? You want it to work without changes, primarily because the Boomla cloud, if you want to ship your website there and just host it there, you don't have control over it. So any change you make, you have to make it to your website. So if you wanted to install something on the system that is adding some extra functionality, make it part of the website. So that way you can just push and pull websites with their story as well across instances of the Boomla platform. And you can have multiple versions as well, and they're not going to conflict. So for example, if you had one version of Apache or PHP installed on your platform, it's getting messy if you want to have, like if you want to upgrade your website, like just say you want to upgrade PHP, then you have to first start with creating a copy of your website, then a copy of the database, and it just gets messy. So in Boomla, because the platform can't change, you can just make new branches of your website, just like in Git, and it will work super easily. File system. So the file system is probably one of the most exciting things, or the most exciting thing about Boomla. One of the interesting features is that Boomla files, like a style.css file, allow you to store other files, like the pattern PNG file. So let me draw this because it's a bit weird. So let's say this style.css file, CSS, is here. And wherever you store a background image or background pattern on a traditional system, well, somewhere else in your project root directory, you would probably have a file named assets or images. Let's call it images. Probably not without the vowels. whatever. And there you would have this image. But the problem with this is that as your system grows, you start adding files in here, and after a while it's a mess and nobody dares to delete anything from it. Same goes for CSS files. You keep adding things to the end, you don't delete anything from there, but we come to that later. So the best way would be to, first of all, well, have small CSS files, but also to store all the dependencies to where they belong, which is here. And don't have this. So in Boomla, every file is a directory at the same time. So data is stored in there and in here as well. And the path of this could be like /CSS, or sorry, well, as on the screen, style.css/pattern.png. Usually I'm asked whether this is a hack and we just show it like this, or is it really stored there, and yeah, let's stop here for a second. There is no file. We are so used to files that we kind of believe they exist. They have been invented in the 60s, I think. And they just work beautifully. You can grab a file on your computer, you can put it on your pen drive, you can walk with it somewhere else, plug it in there and make a copy. You can think of it as a real thing. But files do not exist. I want you to kind of recall this or think about it, because if you realize that files don't exist and that files are just an interface, then you can start realizing that, well, we could define a different interface. So what does it mean a file is an interface? The operating system is essentially promising us that if you create a file and write something in there, then you can later reopen this file, which you can identify by something, in this case a path, and if you read back whatever was in there, you will get back what you previously wrote in there. And there are a couple of more other rules, but this is the basic idea behind the file system. So it is just an interface, it's a contract of how it will work. And if you think about the file system like this, then it's not so hard to imagine a different file system. So instead of having files with directories and that contain other files, we can design an object tree. Really, it's just an object tree with methods and a contract of how it shall work. We can define this new kind of file system and say that, well, each of these objects, each of these things may contain data and may contain children. And that makes Boomla super easy to work with. All right. The second very interesting feature of the Boomla file system is file extensions. Because Boomla, well, in Boomla you're still using file extensions if you want, you don't have to, but they don't really have any meaning. First of all, if I go to this, the root of this website, it says video.meetup.boomla.net. So in Boomla, this is a file as well. Let me just open the IDE so that I can go up there and you can see this is a file, just like all the other things in there are files. So the root object of a website is a file. And the way this file works, the way it serves requests, etc., are defined by the file type. But this can't be .NET, right? Or in case of .com, it would be on Windows, that would be a binary that should execute, so that's not a good idea either. Anyways, you can't really change that. There are a set of extensions, and it's a bad idea to hardcode the way your root file, your website would work. If I open this properties and attributes thing, there you can see the file type. So in Boomla, the file type is a property of the file that is essentially a path to an application that will define how it shall work. Okay, let me close this for now. So going back to here, there are no file extensions. Boomla uses file types instead. And let me give you another metaphor as well. So if you think about file names, it's not much different from your name. And well, back in the early days, I imagine they were in a rush and they just had this file system which was already working with file names that were 8 characters long, and they kind of had to trick this system into working to work with applications, and their idea was to squeeze the file extension into the file name, which is like putting your address into your name. Which is weird. So every time you move to a different place, you should change your name. Seriously? So with files on the web, it's the same idea. And the benefit of not having file extensions any meaning is that, for example, let's say we have this pattern.png, which is, as you would expect, a PNG file, an image file. But later on, you could decide, well, actually, you needed this to be auto-generated. What do you do then? If you're using a WordPress system or any of the website builders I am aware of, you are stuck because, for example, with WordPress, if you're using Apache, the fact that this shall be served to the user as an image is defined not even in your system, but in Apache. There are this list of magic file extensions, which it handles in a different way, and it is external to your project. So you are losing control here. I will get back to this later. So let's move on for now to object-orientedness of the system. So imagine a class. This is not any specific programming language. This is just a pseudocode. So there's a class and there's a function or a method in it named .request. Like if this website or any file in the website would be an instance of this class, it could serve a request by calling the request method on the instance. And this is exactly what is happening in Boomla. So Boomla is object-oriented. One thing that is interesting in it, in that Boomla is everything. In Boomla, everything is a file. So let's say the foo example.com/foo is an application, which is defined in the file type, by the way, so that its type is app1. This is just a keyword, like class. There's no app2. Maybe there will be in the future, but for now, you just have to memorize this. There are not too many types. Like there's another one, but not too many. And the request methods would be another file. So you store that method in the foo file itself. And the benefit of this is that in the future we could have different languages for different applications. So for example, this is a JavaScript. It was originally server-side JavaScript, and this is version 3. And the benefit of this numbering is that we can keep the older versions and introduce new features, breaking features, without actually breaking all the websites. Okay, so there's the request method, and there are of course other methods. And what would you write in this request file for it to work? Here's a super simple example. Let me copy this and give you an example of how this works. So what this does is it's setting the response body, and the response object here is a file. And it's setting an attribute of that file to set the content type that will be returned to the user. So let's open the IDE and create a new file. Let's name it actually foo, so that it's the same. And I'm not going to rush through this. So on the right, you can see we can immediately open this. So we create a new file and we open this totally empty file and we get an error, missing file type for this file. All right, I get that. So I open this properties and attributes and metadata thing and say the type shall be, app1. Save it. open it again. Now it says method.request not defined for file. Correct, we haven't created it, so let's enter this file. Now we see the children, which there are none yet, and create .request. This is a capital R. And let's try it again. Now it's not liking the fact that the request file has no type, which is cool. So let's use this SJS3, save it, reload. Now it has a new issue. The content type is not set. And if you are using the SJS3 interpreter, use this to set the content type. So this is an example. Let's open the file's body. So this is the metadata, properties and attributes. And this is the actual file body, which you would know as the file contents from other systems. Let's enter response.attribute string, content type text HTML, save, and now it returns nothing. And we also want to add some content to it. So let's say response.body, now. And it says now. So it works. So what I want you to notice is that throughout the creation of this simple app, Boomla has been holding our hands. So it has been telling us all the time what is wrong. So it's there to get you started. All right, let's close this and move on. Prototype based. So Boomla is prototype based. It's a prototype based object oriented system where the objects are the files. And we have created an application similar to this one, and now we can create instances. So let me go back here, open the IDE. I've navigated to this page because when you click the IDE, it opens on the same page. As you can see now, we are in the object oriented page. These are the children of that page. So there's this foo, and let's create a foo instance. There it is. And I want to set its type to foo, except this is going to be resolved relative to this file, but this resolving starts inside it. So first I want to go level up to step out of this foo instance and then use this foo file. So that's fine. And if we go to refresh this page, nothing happens because because that's not how it should have. Well, we were not expecting any changes there. So let's open this here, and it says now as well. All right. So it's prototype based. It's inheriting the functionality of the original application, which we have been referencing. So we have seen this response file. This is how we have been returning a response. What about other kind of other files that are available? So if we are talking about an object-oriented system, the very first thing that comes to our mind is the keyword this. In Boomla, there are, well, we can't use this because if we want Boomla to be a multi-language system in the future, there would be a collision. So we are going to have to pick different names. F stands for this. It's actually standing for file, and it's just super short, so it kind of was used all the time and became the de facto this. All right, so this is injected into the virtual machine. So for example, let's go back to this code. There's this foo app, and oh, wait a sec, I think I have written, have I, or haven't I? List, there's this list. Okay, close the others. So this is an app. As you can see, inside this list file, there's a request file, type SJS3 says JavaScript, and there's simply a listing of all these files with their appropriate paths. So let's open this list file here, and it says that this keyword points, or the F variable points to the list itself, because the application and the instance in this case is the same thing, or the same file. Then there's a request in the response file, which exists in a temporary file system. So every time a request hits the server, we set up a new temporary file system, which will be thrown away after the response has been sent back, and it's only available within your transaction. And all the input variables come through the request and the file uploads and whatever, and your response is going back to the user through the temp/response file. There's also a reference to the file that is being executed at the time. Like in PHP, it would have a name like file name maybe. Here you have an object pointing to that. Actually, the app variable name is like a historical thing. We will rename it in the future because the application is actually list now. But never mind, because the interpreters and virtual machines in the system are version controlled, so we are free to change that in the future. And any well, as the system grows, there will be probably more things that need to be cleaned up as the system evolves. So that's normal. And there's a context file, which is telling you what was the original request, which file was originally created, which you need for generating a menu, for example. All right, and as we are here, let's create a list instance and point it to .list and open this list instance as well. So as you can see now, F points to list instance, not list, but still the application file, the source code that is executed is the list/request, so probably as expected. Okay, so these were the special files, and let's see built-in types. So if we go to, actually let me walk you there. So Boomla developers built-in types. These are the built-in types in the system right now. Not too many. There's app1, which is just a meta type. It's like the class keyword defining your file as an application. There's the JavaScript, server-side JavaScript interpreter. And there are a few more like Markdown, and we will see some in this intro. Okay. Let's see static files. So we have talked about this already. So because the file systems are not defining, like they're not, sorry, the file extensions are not selecting the applications. Rather, the file type is selecting the applications. You retain control and can change your mind later and change the way files are served to the user. But also let me talk a bit about static files, the concept of static files. So what does it mean to have a static file? So the original idea behind static files is that static files are just served to the user as is without changing anything, which is a lie. I mean, there are HTTP headers which are also returned to the user, and effectively you're not, so these are not static files or unchanged files served to the user, rather you're effectively just delegating control and losing control over the way those are served. So in Boomla everything is dynamic. You define for everything, every file, how it's served, and it's specified by the file type, but we do have the concept of static files. So if I go back here and list, there is a static one application. So we have the same concept, but the big difference is with Boomla, because it's not in the file name, just rather in the file type, which is a property of the file, you can always go there and change it. So you don't lose control, but you kind of get the same functionality because, well, there is a reason why static files exist. It's just the promise of that is a little bit, well, untrue. Okay, let's see placeholders. So if you create a new web page, let's say by dropping new page, maybe in this, oops, I lost it. I dropped it by accident. All right, my mouse was bad. So if I go to this page, I would say this is an empty page in the way a user would, well, think about it. It's not an empty page in the sense of this. Now this would be a really empty page, but this is not what I want, right? Not what most people want. So for that reason, when you create a new page, you actually create a new instance of an application. And this application is defining some placeholders. For example, in this page, the menu is within a placeholder that is taken from the application itself and the top menu. And there's another placeholder, this one, which is taken from the page instance. So this is great because you can create a page that has some contents on it, but you can have some areas that can be defined by the actual instances. And let me draw this. And here we came to another interesting feature of the Boomla file system. Because normally, and I'm going to just use circles from now, or at least in this case. So normally if you have a directory and it contains children, either files or directories or whatever, these are just in it like in one box. These are the children of that directory. Not quite in Boomla, because in Boomla there are placeholders. So placeholders are like, imagine all the children, this big box, so this is like the big box of all the children, but in there are boxes which are named 0, 1, 2, etc. to 250, this is a 5, to 55. So you can think of them as one big box if you want. You can get the children of that file and you will get all of them. Or you can look at specific placeholders. And this is exactly a feature to support this functionality, which we have seen that you might need various placeholders on the page for various content, and that way you can achieve it. When you're dropping something into the page, it will be rooted in the proper one, as we will see later. All right, pages. What is a page? A page is a file in the system for which it's true that it defines the page interface. So think of its application containing a page method, which in Boomla means that its application contains a page file. Or, because Boomla is prototype based, it means that the page file must exist on its prototype chain. So if I draw again, so let's say that this is an application and maybe it has a .request file. And you create a new instance of that by pointing the type here. And you can have a longer chain as well, etc. Now, this is a file if the page either exists here, or here, or here. So let's say if I mark it as a page by creating this page file, this will be a page, this will not be. Makes sense, I guess. Contents. Contents work just like that, except they have to implement the inline method. Now, the page method is simplified, that should exist because it's not doing anything. But the inline method is actually being called when you write a little program. And you don't need to set the content type in this case because it will be just injected into the HTML code. So for example, let's go into the IDE, and we can see that there's let's verify it here first. So there's a title and there's a markdown file. So this is the same what we see here. And let's create a new file, whatever. And put it to, now it's good at the top, refresh, nothing happens because it's in placeholder 0. So to change that, we have two ways. Either click it, change it, save it, and then it will work. And then we get an error. Or you can drag it here and drop it relative to another one. So let me actually move it back to 0. It's not showing up. By dragging it before title, I actually position it right before title, which means it's in a different placeholder. So for that reason, the placeholder is updated and it will show up as an error. Okay. So it's app 1. Within it, we implement the inline Method, again, this is capital I. Every built-in method has a capital letter, and user space method, so if you invent your own, it must be lowercase. Again, let's use SJS3 for JavaScript, and in the body we say response.body. Hello. Refresh, and it says hello. So what makes this very interesting is not only you have hello here, but you can copy it, paste it after that. You can immediately grab this and move it to another page. So you have an application that is like flexible in a totally new way. Okay, themes. So a theme is simply an application for which the request is defined. If you want to use it as a page, well, if it's a theme you want it, then you have to define a page method as well. And when you create instances, you just have to reference this theme by its path. So I created a very simple example. Let me click this, and we land on a super simplistic theme. The menu is not even implemented, it's just some text here, and there's a placeholder, or maybe it's not. Oh, it is, it's just not droppable. Anyway, it's a minimal application. Let me open this. So this is the example page. Let me go up, example, type, app1. Yeah, by the way, you can also see it here. Let's enter it again. So it implements the request interface. It's marked as a page so that it shows up in the menu. Yeah, actually remove this. Delete. Go back. It's not in the menu. Undo. So we recreated this page file, and now it shows up. Okay, and there's a CSS file, not so important for now. Okay, so this is JavaScript code as well. Let's open it. Effectively, there's just some super simple HTML code in here. What we are mostly interested in is this part. What it says is, relative to the this file, which is the page instance, query the file system, find in placeholder 1 all the contents. There are very few of these shorthands. If you know jQuery and have used it, this is the part that probably is amazing in jQuery. So we borrowed this idea. By the way, you can go to boomla.com, developers, file system, query language, and there you can see column B, column C. This is for pages and contents. All right. So after selecting them, we get back a collection, and then we just inline all of those files. So right now we have nothing in placeholder 1. These are all in placeholder 0, which is, by the way, the default hidden placeholder. Nothing is showing up in page example. But let me go back here. What if we change the type of the very page we are on? So this page. That would be interesting. So let's come here. There's our theme, and its type is app/page. Now let's change it to ./example. What will happen? We are going to use our theme, but because the f variable points to the instance, we are going to take the contents from the page that we were on. So that's super interesting. So we can undo, and well, changing a theme is so much work. You can always install a new theme and use it. Okay, cool. Attributes. We have seen in the IDE that there are 5 properties. So if I come here, whatever, these are 5 properties. For example, a file type, and there are 5 attributes. What are 5 attributes? Well, these are the user-defined things. So the system defines. Anything which is in the attributes, you can define yourself. So let's take an example. Foo string is bar. So what you see, there's a name, there's a type, and there's a value. There are different types like, whoops, I don't know, number int 32 is 34. I want to emphasize that this is not stored like this on the disk. It's just an interface to you because, well, Boomla is a young system. and we didn't get to the point where we are creating a super fancy interface, and that kind of gets the work done. So before giving you like this, it's created on the fly, and when you save this, it's routed back to the proper places. Maybe in the future we can create a different interface, but actually this is just working amazingly well. So for developers, I think that's more than good. All right, so these are, oh, and by the way, if you make mistakes, it will tell you that you can't save it. Okay, so these are attributes. Now, one thing is very important about attributes. I want to draw what you see on the screen, but I want to draw it anyway. So in a database, you would typically have, well, this is the database. Inside the database, you would have some tables, and each of those tables will contain some rows with various columns to hold the actual values. Now, you can achieve the same structure with Boomla, and I call this organization of files kind of a database equivalency structure. So instead of having this database, which is just an object for holding the tables, we can create a file for the tables. You can create a file each for the rows. You can create a file. And the actual values will be attributes in the files. So it's very important that anything you can store in that database, you can also store on the Boomla file system. This is very important because I often get the question, could you store this kind of problem or this kind of data in the Boomla file system? Well, can you store it in the database? Yes, then you can store it on the Boomla file system. No problem here. Yeah, so a Boomla file, it's better if I draw again. I let this one stay here. So let me zoom onto one of those files. Well, it had a parent somewhere and it has children. So inside that object, it has three purposes. Where's my better? This is a better one. So first of all, the file is like working like a file. Second, it works like a directory. And third, it works like a database record. And then the children are stored in it like it's a directory. And in the top, they are like all stored like this. If you want to kind of understand how that works and you have a hard time thinking in a file having both data and children and attributes, maybe this view can help to understand it. But on the disk, this is not stored like individual objects on a Linux or Windows file system. This is actually stored on the disk in a new way, in a new file system format. Truth is, we use a virtual disk file. So on the disk, if you install Boomla, you will actually going to find a file called disk, which is containing all the binary data for the entire file system and all the websites. But that could be on a raw physical disk as well. It's simply that that way you don't have to plug in an extra drive or create an extra partition or whatever to have a local installation. So that makes life for you to work with it much easier. But there are no million files on your disk, on your machine when you create a website and start creating loads of files. And that would be very slow. And now that we are at it, another question I often get is, isn't Boomla slow? Like, it's built on a file system, and file systems are slow, so Boomla must be slow, right? And my answer to that is like, is a car fast or slow? Because the car is a concept, a file system is a concept. Porsche is an instance, it's a realization of the car, and the Boomla file system is one realization, and it's just designed for a different purpose. It's indexed in memory, well, I would say just try it. Everyone who tries Boomla, the first thing they notice is, heck, this is really fast. So Boomla is indexed in memory. It works similar to a database. That's why it's super fast. So you can think about Boomla as a file system that works like a database, or you can think about the Boomla file system that is actually a database that looks like a file system. Whichever you prefer, the main concern is it's super fast and it looks like a file system. Great. Head. If you want to set response headers, in the HTML document, a script in the HTML head, it would be hard. So normally how systems solve it, they give you a function where you can kind of register things that you want to inject into the HTML head. The problem with this is that's not a clean approach because the simplest architecture for a system is the functional architecture, where there are just function calls and everything returns things without any side effects. And if you register something somewhere, for example, that you want this script to be added to the head, that is a side effect. What if your application crashes? Well, most systems don't handle it quite well anyway, but because they will crash, not just the simple application that is there. But anyway, the clean solution would be to not only return the HTML code that should be injected into the body, but also return the scripts and anything you want to include in the head in a separate so separated from the body, of course. So Boomla solved this by having a head attribute. So I think there is no example here. Let me go back to the IDE. There was this theme, for example, and example and request. And here we are setting the content type. You could also say that we want the head to contain this script, whatever you put here, and that will be interesting. Theme and example, and that will obviously break the system because whatever. Oops. So the system is returning the contents that should be injected into the page in the file's body, and anything you write to the head, that will be injected in the HTML head. Files are ordered. So as you have seen, we were dropping images in the galleries, and we were moving contents here. How does it work? How is that mapped to the file system? So as you can see, files are ordered. But that's actually super important. If you think about it, the way databases work for implementing websites, most of the tables usually contain an order ID field. And well, if all of the tables or most of them contain an order ID field, we should start thinking whether we are doing something wrong. Because, well, what is a platform? A platform, the task of a platform is to solve common problems centrally. Now, if you are hacking your database to have an order ID field in most of the tables, then it seems like a common problem. So Boomla says, all right, let's recognize this as a valid problem. And instead of storing these files in no order at all, let's store them, well, ordered. So now that, let's look at the IDE, you have this A, B, C here. And if I grab C and move it before A, it will be moved on the file system as well. So this is natively stored in an ordered way. And also it's very convenient for the users because users never think in terms of order ID. So for example, if B has order ID 4 in this case, or if it starts with 0, then it's, let's say it's 3, then users don't think about, I would really love to change the order ID of this B file to from 3 to 1, and that of C to from 1 to 2, and for A I wanted to change it from 1 to 2. It's like, what? No. What people think, like, I want to grab this thing and put it before that thing. That's exactly how we work, and it's so much simpler in the brain, and, well, the data structures under the system should be supporting us. Okay, more advanced topics. CSS namespacing. What is that? Well, if you have an application that uses the .red CSS class and there's another one, there will be a conflict. So Boomla, the solution to this is quite widespread now. It's called CSS modules, which essentially says, let's use that in your code, but also add some namespace on the fly, both to your CSS file, and use that in your HTML code, and then there will be no conflict. So Boomla has built-in support for that. You can import this CSS file. So here you select the CSS file, add it to response as a CSS module. It's just a helper function. It's returning an object which is mapping the red keyword, which is this, to the namespace equivalent. So in the end, you will end up with this in your HTML code and avoid CSS class name conflicts. External dependencies. Yeah, it's super important that Boomla gives you better data structures to manage complexity, to manage clutter within your project. So being able to store pattern.png in style.css is helps you organize your website in a cleaner way, your code in a cleaner way. It also allows you to create CSS files, for example, that are portable, because all the dependencies are in there. And then there's the special CSS application where you can just reference the pattern.png in the CSS file when you write it, like this, and the name will be modified to, like, expanded to include the entire path of pattern.png, so you don't have to worry about that. I'm not sure if you're aware, Word documents and Excel documents are essentially just zip files with a different name. If you just get an XLSX file and change the file type or the file extension to .zip, you can open it as a zip file and get everything out from there. This is because Microsoft has realized that, well, they need encapsulation, because you're never going to attach a Word document, for example, to an email and kind of search for all the images on your directory and attach those to the email as well, so that you don't forget none of them. We would never be able to send Word documents across to each other. So they have to be, they have to kind of go with the Word document. And essentially, Boomla is offering a native solution for this problem instead of hacking it with zip files, which, if you think about it, is pretty cool. External dependencies. So I just said that Boomla offers encapsulation by storing files in files. Now, dependencies or packages that you install onto your system are another interesting beast. let's go to apps, and there's a paper template. If we open it, you can see it's a super simple theme that you can use on your website. It's paper.boomla.net. Let's install this application on our system. One of the ways is to go the next finish route on the graphical user interface, but we are much more interested in doing it now on the file system. So let's open the IDE, and here let's create a file, paper, and set its type to, it's link to import paper.boomla.net. If I save here, we might get an error because we can't access the file in the same second. That's for other reasons, not that we couldn't. So now, if I reopen this, you can see that there's a hash now, and the file type has changed as well. So now, this website, paper.boomla.net, has been fetched and imported into our website. And the file system that is mounted here is identified by the hash so that it's immutable, so that updating the original website won't change yours. So if I go in here, you can see the entire file system of that website is imported into yours. So that is basically package management in Boomla. To update this, you can just remove the hash. That way you tell the system to refetch it, you can save it, and we open it, and well, it didn't change because obviously that website didn't change in that short time. And also you can open it. And notice that we are on our website, and you see the same documentation that you have been seeing on paper.boomla.net. Let me just open it one more time. So this is paper.boomla.net. This is our imported paper website. It's identical. So the reason that works is that because in Boomla, import links are scopes. So that means the root file within this imported file system points to this paper file and not our root. That's very important because that way it can take its dependencies with itself. So anything it may need for it to function, you will install it on your system automatically with this paper app, with any package that you install on your system. And there will be no issues with, for example, version conflicts. Now, a typical question again is, wow, that will take up lots of space super quickly. And of course not, because Boomla is deduplicating data by its hash. So effectively, importing the same website twice will not produce, will not require extra space. You just need to import it once. All right, and now that we have imported it, I can't. Anyway, let's just, we have seen themes, so I'm not going to apply it. Transactions. So again, sorry, that was dependency management. Now it shows, now that the imported file shows up here because it's a page. So that's how Boomla handles dependencies. Transactions. It's generally agreed that global is evil and that nobody should use it, and yet the file system is a global, and it is an evil because it's global, and we kind of are okay with that. Now, how is this? The reason most basically is that if the biggest gorilla does something wrong, it's kind of right, isn't it? So because the file system is so complex, and we kind of, it's not very practical to roll your own file system, at least not for everyone, because we would not get anything done. That way we kind of accept, and it has always been there, so we kind of are okay with that. But it's still a global, and it's still evil, and Boomla wants to change the way it works because it just it isn't quite right. So in Boomla, architecturally, instead of instead of, maybe I should draw again. So this is your file system. How shall we, anyway, the perfect sign for a file system. This is your file system. When a request comes in and hits your website, we fork your file system. So if you make a copy of your file system, or it looks like a copy, it's not really, of course, and then you're working with that file system. And this file system is effectively an argument for your application. So when your application works, it works on that file system, and then it returns the results, and with the results it's returning the file system. This is under the hood, this is architecturally how it works. Why is that super important? Because if shit hits the fan and you realize that your application runs in a state where it shouldn't and you want to roll it back, if it wasn't forked, you would be forced to kind of make the rollback yourself. But because we have transactions, you don't have to. And also, effectively passing in the file system into the application or having transactions is kind of the similar concept. And if you think about it, having a page, let's say this is the page, this is the first fork transaction. When you want to generate the menu, we create a new fork. When you want to generate this content, this is returned, then we create a new fork. And maybe we want to have two columns here which contain all one file there. Then again, we create a new fork, and then a new fork, and a new fork. So essentially, for every application, your website is forked and then committed back again. And what's the benefit of this? Well, let's see. Let me jump here, sandboxing. So it says, I'm okay. Let's open the IDE, demo, application 1, inline, code is, I'm okay here. Now here's a function that doesn't exist. Let's uncomment and save it, refresh, and you see the error. We have seen this before, but we haven't discussed it. So what I want to emphasize here is that the error message here is caught. It's the result of running that application. And it's a first-class citizen. Like, you can drop it around. It's not bringing the page down. You can even make a copy of that. Why not? Or undo it. Or the simplest way to fix it is, well, undo it again. Other systems, if they encounter this situation, will give you a blank page with an error message that your entire website is down. But Boomla is a platform, and every application is running in a new sandbox, as we have seen with a forked file system. So that way we can catch these errors, and that way writing applications is a lot simpler, because if you see this error message, you can see where the problem happened and fix it. And you also know which application caused it, and you can still just remove it if you don't want it anymore. So these are transactions. And it's eliminating a whole class of problems. For example, rolling back things is typically something we don't implement. The Windows file system is set to contain loads of places with comments, with comments saying, somebody fix this. It's not that those engineers are stupid. Those are extremely smart guys, I'm sure. But these are problems you can't easily back out of. Like, if you have already destroyed something, how do you do it? Like, how do you undo this? If it doesn't exist anymore, you can't. So I guess that's why we see so many blue screens in Windows. All right, built-in version control. So as we have seen, we have undo and redo, and we have seen commit and checkout already, and I've explained push and pull, and we can also create branches and we can merge them back. We have seen the story. So why is it? Why do these exist in Boomla? Well, first of all, if we want to have a proper application platform that allows us to write applications in a I would say professional way, but whatever, in a decent way, we need version control. And the problem is, if we were using an external version control system, not a one built into Boomla, because that's a custom one built for Boomla, then it wouldn't be true that we have an immutable platform, because then we would, for example, if we were using Git and we wanted to export our website to do version control there, then that wouldn't necessarily exist on every system. So we would start to rebuild the stack again with all the added complexity and not being able to just push sites around. So for that reason, version control has to be built in. And the way, and I'm drawing again, the reason it's working so well and so simply in Boomla, because after all these applications are finished running and they are committed back, we effectively end up, if there was any change, we end up with a new version of this file system. So if you know Git, it's the same concept. These versions are created one after the other. And effectively, when you want to undo your website, the active state of your website is simply a pointer. So it says, this is the active version. And when you press undo, we simply change it to say, this is the active version. And then we can have redo again. And yeah, committing simply means that some of them are marked like this is a committed thing. And if you make the next commit, well, actually it's here. If you want to commit this change, it will be added to a different list. This is called the story. And you add some messages here. But effectively, these are just snapshots that are recorded somewhere in the system. One important aspect of this version control is that it's different from Git, and for an important reason. So in Git, if you commit a very large file into the Git repository, you're effectively you're very motivated to get it out there because it will be stuck in there forever. And everyone, if you're working with others, will get that big file and you don't necessarily want that. But the problem is that in Git you don't have snapshots. The hash of a single state of the file system is influenced by all the historic states. So for that reason, to get out a file, for example, for this commit, you have to rewrite the history. That's what's called rewriting the history. And then you're creating a new, which I call a story, but Git calls it a history, a new thing without that big file, which was introduced here, not here. But in Boomla, because it's a document, like websites are effectively big documents, and it's quite common on websites to have videos or whatever other big documents. So for that reason, Boomla needs to support removing things from that storage space that it requires. So for that reason, in Boomla, instead of having these interconnected, like this hash chain where a file affects everything after it, Boomla has snapshots, and these are like independent snapshots, and you can just say that you want to get rid of this one, and you are effectively removing it, and that makes deleting or freeing up space super easy. And it's much easier for end users as well. If sometimes I get a question like, okay, but that way we lose the guarantees that Git has that that nothing is lost. Effectively, for developers, especially bigger teams, the big guarantee that Git is giving is that nothing has changed in the history. No file in the history has been removed, which is a great guarantee. Boomla has a solution for that as well, but I don't want to go into this now. Effectively, for end users, you can simply remove snapshots if you want. By the way, this is not implemented yet. The data structure is in there. The user interface is not supporting it. Installing applications. So that's the place where I wanted to show you this. Anyway, I've already shown this. List of applications. Yeah. These are them for now. You have things like files.boomla.net for a simple file uploader. This install button. If you want to write your own app, you may want to have an install button on it. Some simple things. Layout, floated layout for embedding images in a text. Then column splitters, and effectively at the time of this writing, I'm just working, my priority now is to get way more applications out there, so expect more to come in the future. Updating apps. Well, I've shown you how you can remove the hash from the file link, and you have also seen how to update apps on the control panel, so that was it. Oh yeah, and installing an app can be undone as well. So let's see this one, because that's interesting. Let's say applications, and let's see this file uploader, for example. This one, I want to install it on my website. Meetup, video installed, refresh, new, there's our files app. Maybe I want to upload some images in there. All right, these are the images, and we can see it on the file panel as well, files containing all the files. And now let's say I want to undo everything. So now the files is here, undo, and it's gone. So effectively you can go and say, I want to try this application, but I don't necessarily want to keep it, so I just undo it. Super simple. And also, let's say we have created this, like installed the files app and created this because I have clicked redo. One benefit of this built-in version control is that you can see all the changes you have made. So for example, you can see, like, it's better if, oops, not here. Let's say undo, and refresh this. So here we have files. This is where it's installed by default if you use the graphical user interface. Now it's gone. So let's say show things. Oops, thing, whatever. And now let's go and install it again. Actually, come here, apps, files, the other one, install, meetup, this one. Okay, refresh, new, it's just installed here. Now I want to see version commit to story what changed, and you can see that this is the place where it's imported, so you can go there and you can check it yourself if you want. And there's another one, if you want to add files to the toolbar, it's just a kind of like a directory where you can add files. So the files file here is like this one is simply added, and if you drop it on the page, it's simply copied. It's a deep copy that is created. Okay. Let's move on. Type chain. I have told this, so you can create type chains. Customization. That's interesting. So now that we have the type chain, we can change properties of instances either at the instance level or at higher levels. So you can inherit those changes. So let's come here to display. There's this gallery, and let's add 2 more images to this one so that it looks differently. All right, so for example, here we have changed the margin and also the number of images in a row at the gallery, the instance level. So again, there are 2 galleries. And let's say I want, oops. Yeah, we can also change the aspect ratio. This is not what I wanted to show. So again, customize, and margin, the local value is overridden. We can go a level higher and change the margin here, and that way it will be centrally applied to every gallery on our website. So as you can see, this other instance then inherits the change as well. So that way you can make central changes that is applied to your entire website. And for when you're programming, there is this f.type chain, which is returning a collection of all the files along the chain, and that attribute string color gets the color. So if you would just write, instead of like remove, if you don't write this, just f.attribute string, it would get the color attribute from f. By writing f.type chain attribute string color, you're looking for the color attribute on any file, on the chain, starting at f, going back on the chain, and return the value for color at the first place where it's found. So that's like when you're writing a program, using this inheritance chain, using this type chain to override values along the chain is super simple, or inherit values. And if you don't just want to override an attribute but an entire file, you can use chain select, which is selecting a file along the file chain. So for every file along the type chain, it checks whether it has a file or a child named background.png. If it is found, then it's returned. If it's not, it's not. Then it goes to the next one until the end of the chain. Extending the context menu, it's simply another interface, context menu. Go look it up in the docs. I don't want to go into every detail here. So developers, apps, application files, and there's this context menu file, which is explaining how it works, what you should create for it to work. There are a few others. All right, type safe drag drop. So there's an except file as well. We have just seen it. So there again, there's this except file, which defines what you can drop and where. So for example, let me close this, new. If I drag a page, I can drop a page relative to that other page, but I can't drop it here. Why is that? So that's where this except file comes into play. And its type has to be except1. And there you can define for each placeholder what it requires a file to implement for it to be able to be dropped. Maybe that was a complex sentence. So this defines that placeholder 1 accepts anything that implements the inline interface. So for that reason, a content like a text I can drop here, but I can't drop it before the page because that's invalid. I can drop it in the page because then it would be rooted in that placeholder because that is accepting it. So if it's accepted anywhere, the system will route it into the first valid one. So let's try all these things out by writing a to-do app. So IDE, and let's create a to-do app. Its type shall be app1, and yeah, we can always just go and refresh it. It's not showing up. That's because let's separate the application and the instance this time. So let's create to-do instance. And let's move this under title. Oh, by the way, on the in the IDE, it's fine to have red things. It's simply, this is a kind of a little bit a developer area. Well, integrated development environment is a developer area. So here, it's only showing you whether this would be a valid thing, but if you want to still drop it there, you're okay to drop it there. On the website itself, it's enforced. So here, the type of that is /to-do app, save, and now we should get an error. Great. And within the to-do app, we create .inline with a type SJS3, SJS3, and something to verify it works. Oops. Okay. All right, so how do we want our to-do app to work? Well, we want to show our to-dos. We also want to save anything that is like if a new to-do is created, we want to save it, and in between we want to show a form so that users can create new to-dos. Okay, so how do we go about this? Let's show it first. Usually the way I start is say response.body p and define p equals nothing, so I can append to this, and to show it, so f points is the this file. It points to our to-do instance, and here we can say f dot query. Let's say those shall be in placeholder 1, so contents in placeholder 1. Dot each. We want to iterate on all of them. This is a to-do entry maybe, and here we say we want to show the to-do entries because it can be a larger thing. Let's store it in the file's body, like the name of this. It must not be the file name because the file name may not contain spaces, so it has to be either the file's title, which is similar to the file name, or something else. I'm going to use the body now because that has no length restrictions. And we want to HTML encode it, so there's a utility function util.html encode to-do.body, and maybe after that we want to create some new lines, or a new line and a horizontal line after that. And that looks good enough for me to start with. So if we go into our to-do instance, and inside it we create a to-do entry, just entry, rename entry. It just has to be in placeholder 1, and it has to have a body, whatever, have a shower. Refresh, there is have a shower. If we create a new one, let me just copy this after that, and to entry 2, eat pizza. Refresh, there's eat pizza. Okay. So the display logic is a very simple one, is in place. Now we should present a form. So let me move this to the top. Okay, so the form is like a form with action. So what should happen if this is submitted? Well, it should be routed to the same URL, which we can do with a question mark, and it should be posted, maybe, because it's changing the file system, it has to use the post method. Oops. The screen recording is changing the way my keyboard works, like it's defining some shortcuts. That's why I'm stumbling here. Okay, and here let's have an input field. Input, type text, name equals, I'll come back to this, value equals nothing, fair enough, and let's have a button as well. Button, and maybe add to do. Much nicer like this. Okay, so I said I'm coming back to the name. So the thing is, this is an application, and we might have multiple instances of the same application on the same page. And the problem with this is, if I use a name like to-do entry name, the problem with this is that submitting this form will create a new to-do entry in both instances, because it's using the same name, and in the save logic we are going to look whether this exists. So we can't just use this. So instead of that, we need to namespace it, and Boomla offers support for this. So let's say the to-do variable, or to-do text, or just to-do entry, or variable to-do entry shall be f.prefix variable to-do entry. So this prefix variable, what it does is it's prefixing the variable to-do entry with something like e blah blah blah, or actually e something like a number, and that's unique to every file. So for a different instance, this prefix would be different. So I'm removing this here, and we can use that variable here. And when that form is submitted, we can change here if request.attribute string, because that's an attribute of the request file, actually without quotes. If this exists, let's assign it to entry. So this is assigned to entry. Maybe let's put it in a new line. If entry is not empty, there's a has attribute string method as well, but this is just simpler. I don't want to make it perfect, this little application. I just want to get it done quickly. So if it exists, it was submitted. Then what we want to do is we want to create a new file in F, which you can do in f.new. We want to append it to this. No, actually we want to prepend it to the list, because the to-do list is an ever-growing list, and nothing at the to-do list is ever get done. So let's do os.prepend and name it entry and put it in placeholder 1. That's optional, but we want it in placeholder 1 because it's always very useful to just use 1, because trust me, it's better in Boomla. So that's our entry, and we want to store, actually that's not good to have the same, sorry. So entry text maybe. And let's call this, whatever. It's entry, and here I call it to-do entry. Let's use the same name. And then it's a bad name. Let's call it entry text here. And then this should be var to-do entry var entry text. All right. So now that is a bit clearer. Okay, so here entry text. So we create this file, we set its body, and we are done. Let's save this. Refresh. There's a form, a field to enter it. So maybe draw something. Add to do, and it says file exists. That's true, because we said this. We told the system to create this file. But if it exists, you want it to be automatically renamed. So let's use os.rename. If it exists, rename on conflict. Yeah, send it again. Draw something. Blah. Add to do. Blah. All right, that's interesting. But let's add some more features. For example, I want to rename those to-dos. How can we do that? First, you want to wrap it in div, and maybe like this. Let's just do it for now like this. I don't want to overcomplicate it with pulling in CSS just now. And we have to specify this this div shall, so the Boomla frontend shall recognize this div as containing a file, which you can do with o1 file. I save. We can go to Boomla developers, apps, user interface, o1 file. And it needs some other things. The best way, by the way, developers, built-in types, ASJS3, utility, HTML code. This is one we have been using. You can try everything in the documentation. We have been using f.execution inline, f.inline, and a couple of others, like prefix variable, which is probably here. So here we also need f.html attributes, which right now only means that the developers, apps, user interface, this will be added as well, so the path will be added as well. Might change in the future, so it's better to use the built-in method that is printing anything that is needed here. And let's close that one. Okay. Refresh. No, actually I don't want to. Illegal char, line 21, unexpected token illegal, 21, something is not quite right here. All right, let's close this. Refresh. That was the wrong move. Anyway, now we can see the icons, which is great because now we can move all these files. Or can we? No, we can't, because I used f.html attributes. But we shall use the to-do entry. I was marking the wrong file. But now we can't move it. Yeah, that's the right way. Because by default, files and, well, applications are not accepting anything. So you have to explicitly enable dropping things somewhere. How do we do that? First, in the to-do app, we have to create an accept file to define what instances of that application, instances of the to-do app are accepting. So accept, its type must be accept1, and we define that placeholder 1 shall accept anything that, well, we just want to-do entries and we don't want a gallery in here. So this is the case where we shall define our own interface. Let's say to-do entry. It starts with a dot and a lowercase letter. Let's save this. And by the way, we can just open the accept file and see it's valid. Yeah, it says it's valid. So that's a feature of the accept1 file type, that it has a validator built in. All right, and now we have to create this to-do entry method on the actual to-do instances. But the problem is we haven't set any type for them. We just used dummy files because that was enough at the time. Now we have to revisit this. Let me close that. So if we go back to the app, let me go level up here. So we have to create not only a to-do app, but a to-do entry app. So let's say to-do entry app, which shall be app1 as always. And we have to implement the to-do entry interface. Actually, on the file system, it should be like this. Okay, and now I go back and update the accept file as well. Okay, so now it's implemented and we don't need to do anything else there because the actual logic is here. It's just for kind of marking those files that those are to-do entries. And so here we also have to say that the to-do entry, the newly created to-do entry files type shall be our to-do entry app. Let me save this now and go into to-do entry app and just copy this. That's the simplest way to go. To-do app inline back here. All right, and that's it. Except we already have several instances, so we can either go and update all of them. We could write a little program that updates all of them because there are not too many. I just do the updating, refresh, drag and drop. So now we can sort them. What if you also want to change the text here? Okay, to-do app inline. Here's our little code, and let's say that I want to make this edit table by O1 content edit table. And here you have to add an extra attribute. Again, it's documented in the user interface section of application files. You have to add data O1 content edit table. You have to define what is in here. It's the body. Save. Edit. Refresh, whatever. Edit. Blah, blah. And save. And it's permanent. You have drag and drop, and we have text editing features. Pretty cool. Okay. Last thing is to add it to the toolbar, which we can do by, this is our application. Let's just copy this again. Copy, go to, this is the root file. Close this, root file, sys, new. Anything you add here will show up in the toolbar. Create a new file, name it to-do app, maybe to-do app, and set its type to this. and we will have to set the title, but let me refresh first. So now it's added as an empty file. This is because the to-do app, the title was not set. Refresh, new, now it's set. And maybe I want it at the end, just drag it to the end. Now it's at the end. It's that simple. So to summarize, the biggest aim with Boomla is to finally take everything we have learned, like humanity, from web development, and take the essential parts and create one simple integrated solution so that web development doesn't have to be as complex as it is today. So we are eliminating processes, we are eliminating the database and, well, at least the concept or the extra database that you have to connect and communicate with. And instead present everything as a file, which again is an interface. There's no Linux that you need to worry about because in Boomla you're living in this ideal world. You don't have to worry about system administration. It's fully transactional, it's distributed. You can have a local installation or one in the cloud. And by the way, at the time of recording this video, the binary distribution is not available because, to my greatest surprise, our users were not interested in using it. Obviously, end users were not interested in it, but developers, to my surprise, weren't either. So to be able to move faster, at the time of recording this, it was removed, and effectively I want to grow this team, and in the future I definitely want to reintroduce the downloadable distributed version. Okay. So distributed means that you can push and pull websites from any installation, and you can also, well, the system guarantees you that it will work just like it did on any installation of the platform. It's fast and concurrent, yet it offers synchronous programming. So JavaScript, the language, is one of the biggest problems of that language is that it's asynchronous, meaning that we have a callback hell and we have to cope with it. And like, if you just write a big program in a synchronous way and then in the end realize that you have to introduce an asynchronous function call at the very deep end of the call chain, then you have to rewrite the entire program. So it's a little bit insane. So asynchronous programming is not how our brains work. So for that reason, Boomla offers you a synchronous interface, a synchronous programming environment, just like PHP does. Yet at the same time, in the background, Boomla actually does have high concurrency, and because it's forking the file system every time there's a request, I think here it just should suffice that the promise is that it will be fast and concurrent in the background, and for you the guarantee is that it will, like, you can program it like a synchronous environment and the results will be the same. So if there's any conflict, Boomla will just throw away the transaction, do it again from scratch, and that way you don't have to worry about this. So when you write a program, you can think that you're the only program running in the world at the time your program is running. That's pretty cool. There's no locking issues and things like that. It gives you full version control. Oh, actually, this is not version control, it's just full control. So there are no static files. You can always change your mind later. At the moment, it supports JavaScript as the main language. In the future, I hope to support more. Boomla is giving you better primitives like files in files, scoped file systems, and file attributes. Boomla is object-oriented. It has built-in version control. And yeah, one of my other favorite aspects is that, well, maybe you have heard about functional programming. Functional programming is, I mean, besides me mentioning it in this video already before, functional programming is super simple because the call chain is super simple. There are no side effects, and that makes debugging your code extremely simple. The problem is that most of the functional programming languages are so different from mainstream languages that, well, the mainstream just didn't catch up with it yet. It looks complex and it offers much more concepts that one has to learn. So on one hand, it's super simple. On the other hand, it's like a hairy language that most people don't want to touch. The interesting thing is that even those people writing in functional languages and enjoying the benefits of functional programming, they still have to live on top of an imperative operating system. Like they have to deal with this mutating file system and this ugly mutating imperative world. So Boomla says, all right, instead of having this imperative operating system, which is hard, and the functional programming language, which is the language is hard, the architecture is simple, why not turn this on its head? Why not offer a functional programming platform, well, a transactional platform that is guaranteeing the functionalness of the system by passing around the file system? Why not couple that with imperative languages that are run on top of this functional platform, and the system enforces that every application returns something. So there's no process running in the background. Applications return something. And that way you kind of have little imperative environments in a functional world with the simplicity of the functional thinking. So it's kind of best of both worlds. All right. This is all I wanted to show you. So if you are interested in playing with Boomla, first of all, get in touch. You can sign up and use it right away. So go to boomla.com. Let me open it in incognito. If you go to boomla.com, you can just sign up and create an account immediately. I haven't shown you how you can create websites. Create new websites. You can create, say, pick this one, select, give a domain like that one, create a website, open, and your website is live. You can start playing with it and programming it. So it's super simple to get started. I have recently created a Reddit channel, and I've created it a while ago, Boomla Reddit, but I haven't published it until very recently, so there are no comments yet. So you're very welcome to participate here. I have a newsletter which I will merge with the subscribed users. It's not merged yet, so at the moment it's a separate list. If you want to get the newsletter, shoot me an email to get it. Yeah, and I also am looking at the moment today, as you can see, it's the 20th of March 2018. We have a section. I'm looking for help, employees to join the team, and here are the open positions that are open. Like I always upload this. So if you know anyone who is interested, or maybe you are fitting any of the roles and you find the system interesting, please get in touch as well. And I just hope that you enjoyed it. Thanks for watching. Bye.